We now move on to discussing the double angle identities. So the double angle identities are basically like formulas that allow you to compute the cosine or the sine or the tangent of an angle that has been doubled or multiplied by 2. And it expresses that value in terms of the trig functions of the original angle. The cosine of a double angle has three different identities that could be used based on convenience, whatever we have. So for example, if we know the cosine but not the sine, then I will use this one because it only uses the cosine and not the sine. However, if you have the sine only but not the cosine, then you may use this one because this formula right here, this identity, expresses the cosine of the double angle using only the sine but not the cosine. And if you have both, then you could use any of the three, whichever you want. Doesn't really matter. Now, for sine of double angle and tangent of double angle, we have one formula each. For the sine of 2x, we have that is equal to 2 sine of x cosine of x, and the tangent of 2x equals 2 tangent of x, all that over 1 minus tangent squared. Now, I'm going to take a moment, maybe a minute or two, to explain where these formulas come from, because the explanation is really easy. I think I have already mentioned that these formulas are actually special cases of the sum and difference identities. I mentioned that at the very beginning of this lesson. So for example, let's start with the double angle identity for sine, because it's the easiest one. So if I take this formula right here, the very first one, and I replace the y with x, okay, so wherever I see y, I replace it with x, what are we going to get? We're going to get sine of x plus x, okay, so that would be the left hand side, x plus x, and then this would be sine of x cosine of x equals sine of x cosine of x plus, and then I said we're replacing the y with x, so this would also become sine of x cosine of x. So you would get sine of x cosine of x. And now if you simplify this equation, on the left hand side, this simplifies to 2x, so this would be sine of 2x. And these two, note that they're actually identical, they are like terms. So you have two of them, so that means this is equal to 2 sine of x cosine of x, which is precisely the formula right there in the middle. You don't have to memorize this formula, unless you're a math major. In that case, I would suggest that you do. But okay, so you see that's the very first one. How do you get the other ones? Exactly the same way. So just use the corresponding formula. So for example, to figure out the formula for tangent of 2x, all you have to do is take this one and replace the y with x. And if you wanted the double angle identity for cosine of 2x, same thing. Take this formula right here and replace the x with x. And if you do that, this is going to become cosine of 2x. This is going to become cosine of x cosine of x, which is cosine squared of x. And then this will become sine of x sine of x, so you would get sine squared. So in other words, you would get cosine squared minus sine squared, which is the very first identity right here. Now we have three though, so where does the other two come from? Well, the other two just come from the Pythagorean identity, because if you replace cosine squared with 1 minus sine squared, and we know that that's true, we know that cosine squared equals 1 minus sine squared. That's from the Pythagorean identity. So if you take that cosine squared and you replace it with 1 minus sine squared and simplify it, you will get this. So that gives you the third one. To get the middle one, you do exactly the same thing, but instead of replacing the cosine squared, you replace the sine squared. Sine squared is 1 minus cosine squared. So if you replace the sine squared with 1 minus cosine squared right here and simplify, you will get the one in the middle. And that's how you derive all five. Let me see, 1, 2, 3, 4, 5. Yeah, all 5 double angle identities. Okay, so now let's do the first example. It says, given that tangent of x equals -2 and sine of x is negative, find sine of 2x, cosine of 2x, and tangent of 2x. Okay, let's start with sine of 2x. We want to find sine of 2x. Okay, if we look at the formula, what do we need? In order to apply this formula, we need to know the sine of x and the cosine of x. And unfortunately, we don't know either of them. All we know is tangent of x. So that means I cannot use the formula at all. So our first job then is going to be to try to figure out what is sine of x and then what is cosine of x, so we can plug them in here and get what we're after. Okay, so for that, we're going to start with this information given. Tangent of x equals -2. And we're going to draw a triangle, just like we have done before in the past, to figure this out. Okay, first of all, tangent is, according to SOHCAHTOA, it would be SOHCAHTOA opposite over adjacent. SOHCAHTOA opposite over adjacent. But this is -2, and of course, I would need to reinterpret this as a fraction. So instead of -2, I'm going to think of it as -2 over 1. Then, that means that the opposite is -2, but I can ignore the sign for a second, because this is going to be the length of a triangle, of the legs of a triangle. That doesn't really make any sense to say negative. So the opposite is 2, again ignoring the sign, and the adjacent is 1. Okay, and now we complete this picture, this triangle. So let's call the hypotenuse C. So you use the Pythagorean theorem. You're going to get c squared, hypotenuse squared, equals one leg squared plus the other leg squared. Simplifying, you get c squared equals 1 plus 4, which is 5. So that means c equals square root of 5. Okay, so that means that the triangle completed is 2, 1, square root of 5. Okay, remember that I ignored the negative sign. Okay, so from this picture, we're going to write down what sine and cosine is, and using this information that the sine of x is negative and the tangent of x is also negative, we're going to determine the sign of sine and cosine, what it should be. Okay, so just from this picture, what is the sine of x? This picture, what is the sine of x? Well, sine is so opposite over hypotenuse. So opposite over hypotenuse. Okay. However, they're telling me right here that sine of x is negative. So that means I need to put a negative in here. It cannot be this because that's positive. But it has to be the same numbers because I got those numbers from the picture. All I have to do is make that small correction and say, oh, well, it's supposed to be negative. So it should be negative 2 over square root of 5. And now we got sine of x. Okay, that's because they told us it's supposed to be negative. To figure out the cosine, again, look at the picture. SOHCAHTOA, SOHCAHTOA is adjacent. SOHCAH, cosine is adjacent over hypotenuse. SOHCAH, yeah, there you go. Now, is it positive or is it negative? They told us that sine is negative and the tangent is negative. The sine is negative and the tangent is negative. Now, tangent is negative, but tangent is sine over cosine. So that means sine over cosine is negative. If I know that sine over cosine is negative and I know the top is negative, what does that mean? What does that imply about the bottom? If the whole thing is negative and the top is negative, what does that mean on the bottom? Can the bottom be negative as well? No, right? The bottom has to be positive. Because if it was negative, you have negative over negative, which is positive. But that's not positive, that's negative. So cosine of x, it has to be positive. Has to be positive, so therefore this is right. I don't have to put a minus. So now we found what is both sine and cosine. So that took a little bit of work, okay, but it was basically just draw a picture and use the fact that tangent is opposite over hypotenuse from SOHCAHTOA. Then we ignore the sine for a second and then complete the triangle and figure out what sine and cosine has to be, but remembering to go back and check whether the signs are correct. In this case, we had to make a little correction here, put the negative because they told us that, and then for this one, we had to double check that this was positive indeed. Okay, now let's finish this off. Now we've done the hard part. The easy part is the rest. So what is sine of 2x? Now comes the easy part. Sine of 2x is just sine of x, 2 sine of x cosine of x. And we just figured out that this is negative 2 square root of 5 for the sine and 1 over square root of 5 for the cosine. In simplifying, you get negative 4 on the top, multiplying across the top, and square root of 25, or just 5 on the bottom. Okay, so that is sine of 2x. Now, cosine of 2x. For this one, we have 3 formulas, and we can use whatever we want, because we actually have both. We know what cosine of x is, so we can use that. We know what sine of x is, so we can use that. And since we know both, we can also use that. I'm just going to use this one, the middle one. Okay? But again, you could use any of the three. Doesn't matter. So this is 2 cosine squared of x minus 1. So just replace cosine of x with what it is, which is 1 over square root of 5 squared minus 1. And let's simplify this. This is 2 times, when you square that, you get 1 over 5th minus 1. This is 2/5 minus 1, which is negative 3/5. Do you see? This part is just plug in. So this is the easy part. And then lastly, tangent of 2x. For tangent of 2x, there's 2 ways you could do this part now. For tangent of 2x, we could either say, well, this is sine of 2x over cosine of 2x, because, right, tangent is sine over cosine. And then, well, what is this? We said that sine of 2x is negative 4/5, and cosine of 2x is negative 3/5. So negative 4/5 divided by, or dividing is the same as multiplying by the reciprocal. So it's the same as times negative 5/3. Canceling the 5s and multiplying across, we get positive 4 on top, 3 on bottom. So that's one way you could have done that one. But there's another way of doing the very last one, this one, tangent of 2x, because we could have used this formula instead. If we use this formula, we get the correct answer as well. So just let's do it. Okay, we don't have to, but that's another way we could have done this. Using that formula for the double angle, it would be this, all that, over 1 minus tangent squared of x. And then we know what tangent of x is. Tangent of x is negative 2. So plug it in there. And then this is negative 4 over 1 minus 4, which is negative 4 over negative 3, which is 4/3. Precisely what we had before. Let's now do another example. Okay, let's look at this one. It says, given that cosine of x is 1/3 and sine of x is negative, find cosine of 2x. Okay, we're going to look at the formulas for double angle of cosine. And notice that I actually have 3. We have that one, and that one. And we have to decide, think about this for a second, and decide which one we want to use. The information that we have is that cosine of x is 1/3 and the sine of x is negative. If I choose the first version of the double angle identity, I would have to plug in both cosine of x and sine of x, and I only know cosine of x. I know that cosine of x is 1/3 and sine of x is negative, but I don't know what sine of x is, so I cannot plug it in here. So that means that's not the most convenient version of the identity, because even though we could use it, we will have to figure out what sine of x is first, and that's just work. It's not impossible, we could do it, and it's not hard, but it's just more work. The second version of the identity doesn't require that we know sine of x, so that's the version that we should be using. Alright, so let's copy it here. This is going to be cosine of 2x equals 2 cosine of x, cosine squared of x minus 1. And that's the version we're going to use. If we plug in what cosine of x is, that's 1/3, so that would be 2 times 1/3 squared minus 1. Simplifying, this is 2 times 1/9, just squaring top and bottom. And multiplying, this is 2/9 minus 1, which is 2/9 minus 9/9, which is negative 7 over 9. So the answer is negative 7 over 9. Note that by choosing the middle version of the double angle identity, we completely avoided using sine of x and having to find it first. So that means really this piece of information right here was completely unnecessary. We didn't need it. We would have needed it if we had chosen any of the other two formulas, because in that case we would have had to find sine of x first. Okay, now let's do one last example. Given that sine of x equals negative 3/4 and cosine of x is positive, find sine of 2x. Okay, for this one, let's look at the we have to find sine of 2x. Looking at the formula for sine of 2x, it says equals 2 sine of x cosine of x. So that means we need to know both. We need to know the sine of x and we need to know the cosine of x. They're telling us what the sine of x is, so that means our job is going to be, we have to find what is cosine of x. We have to figure that out. In order to do that, you could do this either doing the Pythagorean identity, cosine squared plus sine squared equals 1. That's the way we learned how to do this back at the very beginning of the semester. Or you could do it using the right triangle. Okay, either way you want to. I'm gonna do it this way again. Alright, so that means we're going to draw a triangle. First of all, let me write down sine of x equals negative 3/4. And according to SOHCAHTOA, that is opposite, so opposite over hypotenuse. Okay, now we draw the triangle. The opposite is 3, or negative 3. You can ignore the negative sign for a second. And the hypotenuse is 4. And now you complete this triangle. Let's call this side A. Then what would you get? You would get that 4 squared, your Pythagorean theorem, equals a squared plus 3 squared. Or in other words, 16 equals a squared plus 9. Subtracting 9 from both sides, we would get 20. No, not 25, but we get 7. 16 minus 9 is 7 equals a squared. So that means a equals square root of 7. So a equals square root of 7. So we can go back here and say this is square root of 7. Okay, now what? Now we can figure out what is the cosine of x, which is what we wanted. So what is the cosine of x? From this picture right here, what is the cosine of x? Look at that triangle and you can think what that is. Cosine of x is SOHCAH adjacent over the hypotenuse. And remember that because I ignore the negative there, you could have put it in there. You actually would get still positive even if you put it there, but also you know it should be positive because of this. This is important, okay? They tell you that the cosine is supposed to be positive. So if you would have gotten if you have put the negative in there and looking at the picture have gotten a negative number, you still have to drop the negative because they're telling you it's positive, okay? Whatever, that's important. Whatever you get, you have to make sure that it matches the information given. Okay, so we found what cosine of x is, and now we can finish this off. So sine of 2x, which is what we're trying to find, equals, according to the formula, 2 sine of x cosine of x, but sine of x is negative 3/4. Cosine of x is square root of 7 over 4. Now we have to simplify this a little bit. Canceling a 2, you would get 1 and 2. And multiplying now across, you would get negative 3 square root of 7 over 8 on the bottom.